Rajiv here from MathVybes, and today we're going to look at the January 2025 paper 1 for physics in detail. If you are somebody that just cares about the answers, here are the answers. Additionally, check the description below because I'm going to include the blank paper ones as well as the solutions there. Question 1. We have to figure out the volume of a liquid. Now, anytime you want to figure out the volume of a liquid, you're going to take your reading at the base of the meniscus. So the base of the meniscus would be right here. Notice my reading is in between 7 and 8, so this is going to be 7.5 because it's in the middle. So my first answer is 1B, 7.5 centimeters cubed. Question 2. In an experiment to locate the center of gravity of a sheet of cardboard, a plumb line string with a small mass on the end is used. The plumb line is used to part D. Show which points are vertically below the pivot. So this diagram should explain it quite well. So this is my pivot over here, and I'm taking a string with a mass and I'm attaching it to the pin. Now, anytime you attach a mass to something, it's going to experience a force that's going to pull it downwards. And so this plumb line is going to be pointing directly downwards. In other words, vertically downwards. So that's why I'm saying it's going to show the points that are vertically below the pivot. Question 3. Which of the following expressions could be used to determine the speed of an object? If we are talking about speed, then the formula there is distance over time. Some of you all might be tempted to put change in displacement over time taken, but this formula would be wrong in this context because this is actually the formula for velocity. Now, a lot of times velocity and speed are used interchangeably, but you need to be able to make the distinction. Velocity is a vector quantity that has size and direction, but speed only has size. So just be careful of this. Question 4. 3 immiscible liquids, P, Q, and R, have densities which differ. Q is denser than P, but less dense than R. Which of the following diagrams shows how the liquids settle in the measuring cylinder? You should understand what immiscible means. Immiscible kind of sounds like immixable, meaning that they don't mix. So they're saying that Q is denser than P. So denser fluids sink. If you are less dense, you float. So since Q is denser than P, P is going to be on top and Q has to be in the bottom. They're also saying that Q is less dense than R. If Q is less dense than R, that means R has to be the densest, and so that's going to be below Q. So my answer is going to be E. Drop a 1 in the chat if you understand what I'm saying. Question 5. When two bodies collide, momentum is conserved. This means that the total momentum of the bodies before impact is equal to the total momentum of the bodies after impact. So whenever you see the word conserved, that means before is going to be equal to after, because nothing is lost. Has to be the same, has to be equal. Question 6. Errors due to parallax can be minimized by B. Placing the eye at right angles to the mark being read. Let me show you what I mean. So let's just say you were trying to take this reading over here, right? Okay. And so if I wanted to take this reading, obviously this reading will have to be taken at the base of the meniscus. Now, when I'm taking this reading, I'm not going to take the reading from this point. To take my reading, I'm going to take it directly at a 90-degree angle from the reading. So this is what I mean. This is going to be you here, looking directly at it. So you're not going to take it at an angle. These two instances would be wrong, right? You're taking it at a right angle to the reading. So just keep that in mind. Question 7. Which of the following statements are true about the spring above? The elastic limit of the spring was exceeded. This is correct. If the elastic limit of a spring is exceeded, it's going to stop being linear. And that would correspond to this region over here. Think about it, guys. Normally, if you have a spring and you extend it a reasonable amount, the spring is going to return back to its original position. But it also makes sense that if you apply more force, the spring is going to extend more. So that's why we're saying if you apply more force, the spring is going to extend. And it should be proportional, and that's Hooke's law. But if you stretch the spring at an unreasonable amount, the spring is going to remain stretched out. So it's not going to return back to its original position. Its original shape. And so that's what this portion of the graph represents. So the elastic limit of the spring was exceeded, right? The spring obeyed Hooke's law over its entire extension. That's a lie, because it stopped obeying Hooke's law over here because the elastic limit was exceeded. Part 3. The force per unit extension in the elastic region was 7.5 Newton per centimeters. Let's look at the units, guys. So we're seeing Newton per centimeters. So what that means, Newton all over centimeters. So where are we going to get a reading on the x-axis for Newton? They have it for us here. So this will be a reading on the x-axis, and this will be a reading on the y-axis. So I'm going to take that reading on the x-axis, put it on top, and I'm going to take the reading on the y-axis, which corresponds to centimeters, and put this in the denominator. And so I end up with 75 over 10. So 10 into 75 is 7.5. And the units are going to be Newton per centimeter or Newton centimeter to the power minus 1. So 1 and 3 are correct, so 7b. The moment of a force is defined as the product of the force and its perpendicular distance from the turning point to the force. Right, so the formula they're talking about here is T is equal to force multiplied by the perpendicular distance from the pivot. Question 9. A glass marble X moving with a speed of 6 meters per second collides head-on with an identical stationary glass marble Y. What is the speed of Y after collision, assuming that X is brought to rest? So in this collision, after X is stationary, and if X is stationary, that would have meant all of the momentum from X was transferred to Y. And so Y should technically be moving at a speed of 6 meters per second. And this is an example of Newton's cradle. I'll provide an animation for that. But let me still show you guys the full working, right? So remember, momentum before is equal to momentum after. So I'm going to draw two marbles, right? So this is the before situation, and I'm going to do the after situation here one time. So we're going to call this marble X. We're going to call this marble Y. Marble X is initially moving at a velocity of 6 meters per second. In that direction, I'm going to assume, right? This one is stationary, so that's 0 meters per second. And since they're identical, they're going to have the same mass. I could call it M, right? And this would be marble X, this would be marble Y. After the collision, marble X is now at 0 meters per second. The mass remains the same, right? For marble Y now, we want to find its velocity after. So we don't know what that is. So we don't know what V is for this one. So V is equal to unknown. And remember that the mass is the same, so M. So the momentum before, remember momentum is mass by velocity. And so for X before, it's going to be M by 6 plus M by 0. So that represents before. And that is going to be equal to M by 0 plus M by V. So on the left hand side, that's just going to simplify to 6M because 0 by anything is 0. And on the right hand side, M by 0 is 0, so you just end up with M by V. So to find for V, I would divide both sides by M. So that I would get rid of the M. When you do that, the M's cancel off, and you realize you get V to be 6 meters per second. Right, so that's how you prove it there, full working. An object with a mass of 45 grams is lowered into a measuring cylinder containing 45 centimeters cube of water. When the object comes to rest at the bottom of the cylinder, the volume reading on the bottom cylinder rises to 75 centimeter cube. What is the density of the object? So they want us to find for density. Density is mass over volume. So we have the mass already, 45 grams. We need to figure out the volume of the object. Think of this. If all objects have a volume, right? So they take up a specific volume. So by adding that into the measuring cylinder with water, you are displacing a certain amount of volume. In other words, you're adding a certain amount of volume into it. And so if I wanted to find that increase in volume, which would correspond to the volume of the object, I would just simply subtract 45 centimeter cube from 75 centimeter cube. So the volume would be equal to 75 minus 45. So V is equal to 30 centimeter cube. And so the density is going to be 45 all over 30. And this should simplify to 1.5 grams per centimeter cube. Notice I did not convert my units to kilograms, because in the question they are specifying that the unit is gram per centimeter cube. So take note of that. Question 11. Power can be defined as work done over time. Remember, power is equal to energy over time. And what is energy? Energy is just simply work done. Alright, so D. Question 12. What is the magnitude of the resultant force acting on the object? So with these kind of questions, I would like you to consider the vertical components first and then the horizontal components. But you're comparing them, but you're looking at them separately. So let's consider the vertical forces first. So if I have a force of 2 newtons acting upwards and 7 newtons acting downwards, that would mean that my resultant force would be a downwards force that's acting 5 newtons downwards. Okay. And let's look at the horizontal components now. So the horizontal components here is 3 to the left and 15 to the right. And so what's going to happen is you're going to end up with 12 newtons because we're going to take away 3 from 15 and that's going to result to be 12 newtons to the right. And so I end up in this situation. Now, anytime you have 2 forces acting in different directions, the resultant is always given by the diagonal. So I have to find the diagonal, which should be given by this. And to find the diagonal, I'm going to replicate that 12 newtons to the bottom, and I'm going to replicate that 5 newtons to the right. Essentially, we make a right angle triangle. Since I replicated this force to the bottom, this is also going to be 12, and this is going to be 5. So if I want to find the hypotenuse, I'm just going to use Pythagoras theorem. Remember, Pythagoras theorem says that the hypotenuse squared, so in this case r squared, is going to be equal to 5 squared plus 12 squared. So r squared is going to be equal to 25 plus 144. So that's equal to 169, and the square root of 169 is 13. And so that's the answer. Drop a 1 in the chat if you understand what I'm saying. Question 13. The pressure due to the water is the greatest at Q. The reason for that is because, remember, pressure as a result of a liquid is equal to height by density by gravity. I would advise you to check the 2024 June paper 1 solution, where I gave an example and I did a worked example. But basically, if I increase height and keep everything else constant, my pressure is going to increase, right? And so the greatest height here is in this specific example. Because if I draw the other heights, you'll realize that in this instance, the height from the top of the fluid to the point Q is the greatest. So the pressure is going to be the greatest at point Q. Question 14. A student sets up a simple pendulum and finds that the period is 1.7 seconds. To obtain a period nearer to 1 second, he should, anytime you want to decrease your time period, you should shorten your pendulum. So I'm going to provide 2 animations here. Now I'm going to show you guys what happens in the time period when you shorten the length of the pendulum. So you could clearly see that by decreasing the length of the pendulum, the time period decreases. Let's move on to question 15. Which of the following quantities has the same value of 6 microcoulombs? So guys, here is a list of all the prefixes you need to remember, but micro means 10 to the power minus 6, so the answer is E. Question 16. An ice cube sinks in liquid A but floats in liquid B. Which of the following statements is true? So guys, I have a question. Where would you all float better? Would you float better in a pool or in a very salty sea? The answer should be in a very salty sea, and that's because the salty sea is going to be more dense. So denser liquids, they have a greater buoyant force, and so they would provide a greater upthrust. So if the ice cube sinks in liquid A but floats in liquid B, that means the upthrust in liquid B is more than the upthrust in liquid A. So consequently, I could say the upthrust is less in liquid A than in liquid B, because in liquid B the upthrust is more. Question 17. The graph shows that solidification starts at Q. During which of the stages is the substance in the liquid phase? So guys, in this question we have a cooling curve. So we would have started off here as a liquid, right? And we are solidifying here, And at this point, we're at a solid. So at this point, you're a liquid. At this point, that's latent heat of fusion. And at this point, you are a solid. So my answer for the question 17 is D, because you are in the liquid phase from P to Q. The heat capacity of a substance is defined as the amount of heat energy needed to raise the temperature of the substance by 1 degree. A lot of people might have put the wrong answer, right? You need to look out for when they use specific and when they don't use specific. Anytime you see specific, make sure your answer includes mass. Anytime you don't see specific, your answer just needs to include raising the temperature by 1 degree or 1 Kelvin. Keep that in mind. Question 19. As the temperature of a liquid decreases, the kinetic energy of the molecules decreases. So when you decrease the temperature, you are extracting energy from the solid, the gas, whatever it is. You are extracting energy. So if the temperature decreases, you are extracting the kinetic energy from the molecules, and so the kinetic energy of the molecules will decrease. And if it decreases, then the molecules are going to sort of move about less, and the forces of attraction is going to increase. That's why when you freeze, water it turns to ice. Question 20. Which of the following play a role with respect to the greenhouse effect? So when we are talking about the greenhouse effect, we're basically talking about the trapping of heat. And which ray over here carries heat? The answer is C. So infrared rays are the rays that carry most of the thermal energy. 21. A student wants to conduct an experiment to determine the specific heat capacity C of a solid using the electrical method. Which of the following equations should be used? So in this particular question, I'm going to recall a good bit of formulas. First one I'm going to use is E is equal to mc delta theta. Why? Because this formula has specific heat capacity in it. So in this formula, if I want to make C the subject, first of all, I would have to divide both sides by m delta theta. So let me do that. And why am I dividing both sides by m delta theta? I'm doing this so that on the right hand side, the m's would cancel off and the delta thetas would cancel off. So I end up with C is equal to E all over m delta theta. Additionally, I would like you all to remember that energy is equal to power by time. And if we're talking about using an electrical method, you have to remember that power is equal to IV. So power is equal to current by voltage. And so if I make a substitution here, E is going to be equal to I by V by T. And so this is what E could be written as. And if that's the case, I can make my final substitution. And so C is going to be equal to I by V by T all over m delta theta. So that is why my answer is E. Question 22. A gas occupies 2 meters cubed at 27 degrees Celsius at a pressure of 1 atmosphere. At a pressure of 2 atmospheres, it occupies a volume of 1 meter cubed. What is its temperature at this new volume and pressure? So in this question, they are giving us volume, temperature, and pressure. So we have to use the combined gas law. The combined gas law is P1V1 all over T1 is equal to P2V2 all over T2. In any gas law question, you need to convert the temperature to Kelvin. To convert temperatures to Kelvin, you are adding the temperature in degrees Celsius to 273. That's how you make the conversion. So that's 27 degrees Celsius there is going to turn to 27 plus 273, and that's equal to 300. Right. So my initial pressure would have been 1 atmosphere, my initial volume would have been 2 meters cubed, and my initial temperature would have been 300 Kelvin. So let me write that down. So my initial pressure was 1 atmosphere, my initial volume was 2, and my initial temperature was 300. Cool. My new pressure is 2, my new volume is 1, and I'm trying to figure out my new temperature. So 1 by 2 is 2, all over 300 is equal to 2 all over T2. So I'm going to cross multiply. If I cross multiply, I'm going to get 2 by T2 is equal to 2 by 300, which is 600. And so to find for T2, I will divide both sides by 2. And so T2 is going to be equal to 300 Kelvin, the same temperature at which we started off at. So just remember, 300 Kelvin is 27 degrees Celsius. So the answer is C. Drop a 1 in the chat if you understand what I'm talking about. So that's it for question 22. Let's move on to question 23. Which of the following statements provides the reason for this occurrence? So what's happening here? Water is boiling at the top, however, the ice remains unmelted at the bottom. The reason for this is the water is not doing a very good job at absorbing and transferring the thermal energy. So a good bit of thermal energy is absorbed over here, but it's not transferring it to the ice wrapped in the metal gauze. So the answer is A. Water is a poor conductor of heat. 24. Which of the following is not an example of evaporation? I think it's quite obvious, this one. A copper wire placed around a block of ice gradually cuts through the ice. That is not evaporation. That have nothing to do with evaporation. Right? 25. Which of the following are reasons why a hot liquid placed in a double-walled vacuum flask retains its heat for a long time? So the answer is 1 and 3. The reason why 2 is wrong is because it makes no sense. If you are trying to regulate the temperature of something, you're trying to keep the temperature constant. Why would you want to absorb heat from the surroundings? Because if you absorb heat from the surroundings, then you are changing the temperature. And the main goal of vacuum flasks is to maintain a specific temperature. So this one is wrong. 26. A detector of thermal energy is placed an equal distance in turn from each of 4 vertical faces of a hollow metal cube full of hot water. So imagine this, right? We have a metal cube and we have hot water inside the metal cube, and we have 4 sides, right? Each side has a different property. So the reading on the detector is greatest when the detector is turned towards the face which is painted dull black. Black surfaces are excellent absorbers of heat, and they are excellent emitters of heat. So the answer is B. 27. The energy required to change the state of a substance was determined to be EH. So in this particular question, we're talking about a change in state. So we're talking about these formulas. So E is equal to MLV or E is equal to MLF. Either one could work in context of this question, it doesn't matter. Essentially, look at what's happening. So in this case, I'm going to use E is equal to MLV, but it does not matter. So if I double the mass, look at what's going to happen. So the mass is now going to be 2 times M. It's going to be 2M LV. Okay. And I want you all to remember that MLV was equal to E. So MLV is going to be 2 times E. So if I double the mass, I'm going to double the energy, as you can see here. E will have been the initial energy, and if we double the mass, it's going to be 2 times the energy. 28. According to the principles of heat transfer, which of the following statements incorrect? The answer is D. Why is D incorrect? Think about it like this. Heat always flows from a region of high temperature to a region of lower temperature. Think, for instance, a metal spoon in boiling water. Doesn't the heat travel from the base of the spoon to the top? And that's because temperature always requires a gradient for it to be transferred, always from hot to cold. 29. Which of the following statements concerning characteristics of steel and iron is correct? So here's the thing, right? Soft iron is easily magnetized. Now it's easily magnetized, but soft iron does not really retain its magnetism well. Whereas steel is hard to magnetize, but it can retain its magnetism really well. So the answer is B. Question 30. Which of the following distances represents the wavelength of the vibration? So in this question, we have a longitudinal waveform. And in a longitudinal waveform, we have rarefactions and compressions. So what is a rarefaction? A rarefaction is when the slinky is going to expand out, and a compression is when the slinky compresses inwards. So wavelength could be figured out by the distance between 2 successive rarefactions or two successive compressions. So an example of an answer would be from A to C, or I could say B to D, or I could say C to E. You get the idea. And so C to E is the answer, so 30C. If sounds of different frequencies are played in succession, in which of the following properties would a change be detected? So we are playing frequencies, but in succession. So as we keep playing, the frequency increases. So let me just say we start off with 10 Hertz, right? Then we reach 100 Hertz. Then we reach 1000 Hertz. Recognize what's going on. If I'm playing frequencies in succession, or it could even be lower frequencies, right? I could start off at 10, go to 5, then go to 1 Hertz. But the main thing that you need to recognize is if you are changing frequency, you are changing pitch. Remember, frequency has to do with pitch, either how high or how low something is perceived. 32. Which of the following types of electromagnetic radiation causes tanning? So the answer should be obvious. It's ultraviolet, because when you go in the pharmacy, you can clearly see that the sunscreen protects you from UV rays, because UV rays are the harmful rays that can penetrate beyond your skin and cause long-term damage. Question 33. Which of the following are laws of refraction? Well, the first one is definitely correct. The second one is wrong. They are talking about reflection over here, right? Part 3 is also correct. I'll provide a diagram which explains the third one, because a lot of people don't understand this. 34. The note from a drum is louder when it is struck harder because the sound waves produced have a greater amplitude. Remember guys, amplitude corresponds to how loud something is. Frequency corresponds to the pitch of something, whether it's high pitched or low pitched. Question 35. In which material would light waves have the slowest speed? Let me give a little example, right? Where would you run faster, in mud or in air? The answer should be obvious, right? In air. So the denser something is, the more it's going to slow down the velocity, or it's going to slow down the speed. So the answer is diamond, right? Because diamond is the densest medium here, and it also has the highest refractive index. Question 36. A wave has a wavelength 5 centimeters and amplitude 2 centimeters. So if it has a wavelength of 5 centimeters, then from start to the end of the wave, it should be 5 centimeters. And if it has an amplitude of 2 centimeters, it should go up to 2 and it should go down to 2. So why the first one is wrong? Because this one has a wavelength of 10. Yes, it has an amplitude of 2, but it doesn't have a wavelength of 5. Part B. Part B is correct because it has a wavelength of 5. It goes up to 2 and it goes down to -2. So B is the answer. Question 37. Which of the following statements about the two waves is true? Q is louder than P, but P has a higher pitch. Why am I saying that? Notice, wave Q goes up to a higher point than wave P. Remember, amplitude corresponds to the maximum displacement, how high or how low a graph goes. So clearly, wave Q is louder because it goes up to a higher and lower point. And P has a higher pitch because its frequency is greater. I would like you to think about frequency as the amount of time a wave oscillates. Clearly, the wave is oscillating at a greater frequency than wave Q. That being said, wave P has a higher pitch because the higher frequency corresponds to high pitch and a lower frequency corresponds to low pitch. 38. The wavelength of the wave is equal to the distance. Right, so recall that if I want to find wavelength, it's always the distance between two successive troughs or two successive crests. What exactly is a crest? A crest refers to the top point of a graph, and a trough corresponds to the lowest point of a graph. So this over here would correspond to a crest, that's point P, and this would correspond to a crest. So the wavelength would be P to S, because that's the distance between two successive crests. 39. Which of the following diagrams represents the diffraction of water waves in a ripple tank? Why is 1 wrong? You probably can't see it, but 1 is an example of total internal reflection. And so this is refraction, right? Part 3 is also an example of refraction because look at what happens. There's a change in the wavelength when it goes from one medium to another. Direction also changes. The only one that corresponds to diffraction is 2, And what exactly is diffraction? The diffraction is the spreading out of a wave when it has to pass through a slit whose distance is about the same size as the wavelength or a little more. Right, so that's what diffraction is. It's the spreading out of a wave when it has to pass through a very narrow slit. So my answer is 2. Question 40. In this question, two coherent light sources produce an interference pattern on a screen of bright and dark fringes. So they want us to figure out the reason why bright fringes are formed. So we have two waveforms interacting with each other. So whenever you have two waveforms interacting with each other, there will be points where the waves will be in phase, and if the points are in phase, they're going to combine, and that's called constructive interference. So in this case, if they align, then it's going to produce a bright spot. But if destructive interference happens, that means that the waves are out of phase, then they're going to cancel off, and that's going to create a dark spot. So if it produces a bright fringe, then all the crests are in phase along these points. Question 41. Which diagram best shows the path taken by a ray of light through a rectangular glass block? Just a couple pointers. If you are going from more dense to less dense, then the refracted ray bends away from the normal. And if the refracted ray bends away from the normal, that means the angle of incidence is going to be less than the angle of refraction. If you're going from a less dense to a more dense medium, this means that the refracted ray bends towards the normal. And so your angle of incidence is going to be more than the angle of refraction, because after it's going to bend towards the normal, so it's going to get smaller. So the answer here is C. And an additional thing you should know, anytime you are going into a medium and you're coming out, the initial incident ray is going to be parallel to the resulting refracted ray. This is what I mean. Check it out. If I were to extend this line, you'd realize that they are parallel. So none of these other options have that property. This one is looking tempting, but it's clearly not parallel to the resulting refracted ray. So D is wrong. The answer is C. Question 42. The amplitude of the wave is, now some people might be quick to put 8, but 8 is wrong. The amplitude corresponds to this portion over here or this portion. So that's going to be half of 8, which is 4 centimeters. Question 43. Which of the following statements about insulators are true? 1. All electrons are bound firmly to the atoms in an insulator. This is true because if you are a conductor, there needs to be a net movement of electrons. But if there's no movement of electrons, then it can't conduct. And if the electrons are bound firmly, they can't really move. So 1 is a very true property of an insulator. 2 says that in an insulator many electrons can move. No, that's a lie, right? And this directly conflicts with 1. Part 3, an insulator could be charged by rubbing. That's true. Think of a glass rod or a polythene rod, for instance. Which of the following diagrams represents the electric field that exists between two oppositely charged point charges? I just want you all to remember that if you have a positively charged particle, the electric field lines are going to extend outwards. And if you have a negatively charged particle, the field lines are going to extend inwards. And obviously, since they are oppositely charged, they're going to attract each other. So the positive is going to extend outwards and is going to be attracted to the negative, right? And this is the only diagram that reflects these properties. So 44A. 45. Which of the following circuits is electrically the same as the circuit above? So in this circuit over here, we have a series connection. Some of you might be wondering, well, how do I know it's a series connection? Anytime you have one singular pathway for current to flow, you're dealing with a series circuit. If I were to draw the direction of the conventional current, you'll see that the current goes in one loop. So we have a negative and a positive terminal over here. So I'm going to put in the direction of the current. And when I do this, recognize there's only one path for current to take. So this is a series circuit. The same thing happens for this circuit. There's only one path for the current to take, and so it has to be A. All the other answers are wrong because all the other answers represents parallel circuits. Why am I saying that? Check this one for instance. Notice how the current is splitting at this junction. That can't be a series. That's parallel. Same thing over here. Notice the current is splitting at this junction. It's parallel. Same thing over here. Notice the current is splitting at this junction. Can't be series. That's definitely parallel. Question 46. Which of the following combinations correctly identifies the currents? So, current 1 and current 2, they clearly have the same peak value because both of them are going up and going down to the same current value, right? That being said, both of them have the same peak value, so neither has a greater peak value. Additionally, the one with the greater frequency is 1. Think of it. When I say it has a greater frequency, that means there's more oscillations in the same given time. Can you see that? So how much oscillations do we have here? So we have 2 full oscillations in the same time period as we have this. This will be 1 1/4 oscillation. So if it's more frequent, the frequency is more. And if you actually wanted to find the frequency, you could do that. Remember, frequency F is equal to 1 over T, 1 over the periodic time. And so that's going to be, for 1, it's going to be 1 over 0.01. Why am I saying that? The periodic time is the time it takes for 1 full oscillation. And so, for current 1, it took 0.01 seconds to make a full oscillation, right? So 1 over 0.01 is going to be 100 Hertz. And if I wanted to find the frequency for the second waveform, that's going to be 1 over 0.02. Why is it going to be 1 over 0.02? Because 0.02 seconds is the time it took for 1 full oscillation. So 1 up, 1 down, right, 0.02. And 1 over 0.02 is equal to 50 Hertz. So you can see it numerically here, that wave 1 has a higher frequency than wave 2. In other words, you can see that in the same time, this had 2 oscillations, and in the same time here, this just had 1 oscillation. So this is oscillating 2 times as much as this wave. Question 47. Which of the following options shows the name of each component correctly matched with its number? So, number 1 is a bulb, number 2 is a fuse, number 3 is a diode, and number 4 is a resistor. So that corresponds to D. Question 48. Item 48 refers to the following diagram, which shows a small negatively charged dust particle. So it's negatively charged. If it's negatively charged, it'll be attracted to positive. Keep that in mind. And it's midway between 2 plates, being observed with a microscope. Which of the following arrows correctly indicates the direction of the movement of the dust particle when the switch S is closed? So if the switch S is closed, this side over here is connected to the positive terminal. So this plate is going to become positively charged. And this plate over here is going to become negatively charged. So this particle is negatively charged, so it's going to be drawn towards the positively charged plate, which is this plate. So it's going to move downwards. And so my answer is C. Question 49. Which of the following diagrams represents the magnetic field which exists between 2 opposite magnetic poles? If we are talking about 2 opposite magnetic poles, then we're talking about a north and a south. Just remember that the magnetic field lines always goes from north to south. So the answer is C. In item 50, they want us to figure out the frequency of the voltage time graph. So remember, frequency is 1 over time period, T. So the answer is D, 1 over T. Question 51. Magnetic induction occurs when C. Iron nails near a magnet become magnetized. So guys, you all wouldn't know this at this level, but if you pursue electrical engineering at a tertiary level, you'll get what I'm talking about. So all the ferromagnetic materials like iron, they have domains, and in the domains there are spins and orbitals, and you can think of these like small weak magnets. And when you bring a magnetic field close by to a ferromagnetic material, these domains, they align with the magnetic field, and in that instance they temporarily become a magnet. And this process by which a nail or something that's a ferromagnet becomes magnetized without direct contact is called magnetic induction. 52. For a simple AC generator, which of the following graphs will be produced by 2 complete rotations of the armature? So when we talk about 2 complete rotations, we're talking about generating an up and a down, right? And if I do it again, I'll generate another up and another down. So my answer is D. I will provide an animation so you can see what I'm talking about right here. Right, let's move on. Question 53. An ammeter has a very low resistance so that it can be placed in. So an ammeter measures current, and current needs to flow through the ammeter in the circuit. So I will place the ammeter in series. Now, if I'm placing an ammeter in a circuit, I don't want it to add in any resistance. So ideally, the ammeter should have a very low resistance so it doesn't mess with the current in the circuit, right? All I want the ammeter to do is just read current, and that's it. I don't want it to do anything but read current, right? So ammeter cannot be adding resistance to the circuit. Otherwise, it would affect the properties of the circuit, right? So it must be in series so the current can pass through, and the resistance must be very low. 54. According to Rutherford-Bohr model of a neutral stable atom, if N is the number of neutrons, P is the number of protons, and E is the number of electrons, then for all elements, P must be equal to E. We're talking about a neutral. Neutral means not charged. And so if it's not charged, then the amount of positive charges, protons, must be equal to the amount of negative charges, electrons. So that, think of it like this. If you have +5 and -5, that would cancel off, right? So that'll be 0, that'll be neutral. It's the same concept. 55. Which of the following statements about radioisotopes is true? C. They are sometimes used in medicine. I'll provide a list here of some commonly used radioisotopes in medicine in case it comes for the paper one. 56. Which of the following describes two properties of an alpha particle? So an alpha particle exists as a helium nucleus in nature. And a helium nucleus is 42He, and they are positively charged but not very penetrating. As a matter of fact, they are the least penetrating. Right after alpha, you have beta, and then you have gamma. Gamma could pass through nearly anything. 57. Which of the following scientists discovered radium? Big up Marie Curie. She died doing what she loved. I respect that. That might be me. Which of the following graphs shows how the activity of a radioactive source varies with time? So we're talking about radioactive decay. Anytime we're talking about radioactive decay, we're talking about an exponential decay curve. So this is clearly not an exponential decay curve. This is a linear graph. That's wrong. We have another linear graph here. That's wrong. I'm not sure what this is. That's wrong. This is an example of an exponential decay curve. So what happens is you start off with the original amount, and as time passes, it decreases until it approaches 0. And these are the types of graphs you all should be familiar with. You should be accustomed finding half-life for these types of graphs, right? So this is what they are talking about when we talk about radioactive decay. 59. Which of the following equations is correct? So the only one that's correct is C. All the other options are wrong. And let me show you why C is the correct answer. So alpha particle is 4 on top, 2 in the bottom. So it has a mass number of 4 and an atomic number of 2. So if I have 226 on the left hand side and 88, then on the right hand side, when I add up everything, it should be equivalent. 222 and 4 is 226, 86 and 2 is 88, so that's correct. So C is my only correct answer. 60. In the scattering experiment conducted by Geiger and Marsden, some of the alpha particles were deflected. Now if the particles were deflected, that would have meant that they would have went very close to the nucleus. Remember, the nucleus is positively charged, and alpha particles are positively charged as well. So if it goes very close to the nucleus, it's going to be deflected because positives and positives are not attracted, they repel each other, and so it will deflect it. Right, so that's why the answer is D. The nuclear charge and the mass are concentrated in a small volume in the atom, and we're talking about the nucleus there. Right, so that's it. So best of luck, guys. See you all in the marathon.